Good morning to one and all. I am Parthiban, working as an assistant professor in the Department of ECE, Sri Muthukumaran Institute of Technology, Mangadu, Chennai. Now I am going to present the subject called Electron Devices, which is coming under the regulation R 2025. The subject code is EC25C01. Particularly, I am going to talk about the Unit 5, which deals about the LEDs, LCDs, as well as about the optocouplers. So in the last class we have seen about the LCD. So LCD is nothing but the liquid crystal display which does not generate energy on its own light. Instead, it controls the transmission of light using the liquid crystal molecules placed between the two polarizing filters. A backlight or ambient light provides illumination, while the liquid crystal layer determines the regions appear bright or dark. The basic components that we are using are it is a front polarizer, a rear polarizer, a glass substrate, transparent electrodes, the liquid crystal layer as well as the backlight. The working principle, as I already told you, without an electric field, the twisted liquid crystal molecules rotate the plane of polarized light, allowing it to pass through the second polarizer. When a voltage is applied, the molecules align with the electric field, preventing the rotation of the polarized light. The second polarizer blocks the light and making the region appear to be dark. So this type of light entering the display is guided by the orientation of LCD molecules that are twisted by 90 degrees from the front glass plate to the rear glass plate. So this twist allows the incoming light to pass through the second polarizer. Next, when a positive image is defined as dark characters are displayed on the light background. This is the most common display mode in calculators, digital watches, as well as in many industrial display panels. The construction we can say in a positive image LCD, the front and rear polarizer are positioned perpendicular to each other. The liquid crystal molecules are twisted by approximately 90 degrees between the two glass plates. Then the operation without voltage we can classify as with voltage. In the without voltage, the incoming polarized light is rotated by twisted liquid crystal molecules. The rotated light passes through the second polarization. The background appears to be bright. With voltage, it differs. The liquid crystal molecules straighten and align with the electric field. They no longer rotate with the light. The second polarizer blocks the light. They energize the segments that became dark. Thus, by applying voltage selectively to segment electrodes, produces dark characters on the background. So this is the basic mode of operation that can be go for a LCD. So in the next slide, what we are going to see is about the negative image LCD, or we can say the response time. A negative image is defined as the bright characters on a dark background. It is commonly used in automotive dashboards as well as in premium digital watches and in modern instrument panels. In a negative image LCD, the front and rear polarizers are parallel to each other. The background is dark because the light is largely blacked. When a voltage is applied to the selective segments, those areas allow light to pass through and appear bright. So we can compare the positive image and negative image. Positive image may have dark characters, negative image may have bright characters. Positive image may have light background, negative image may have a dark background. Positive image may have a crossed polarizers, whereas negative image may have parallel polarizers. Positive image is generally used in calculators. The negative image is commonly used in automotive displays. So here coming on to the LCD response time, it is the time required for the pixel to change its optical state after an application of or removal voltage. It determines how quickly the display updates and is important for moving images. The types of response time, we can say it is an on response time. It is nothing but the time taken for an off pixel to become visible after applying an appropriate derived voltage. What is that off response time? It is a time required for an on pixel to return to off state after removing the voltage. The factors that are affecting the response time are namely the temperature, the viscosity of the liquid crystal that we are using, the dry voltage, the cell thickness. The factors that affect the response time are the effect of temperature also plays a crucial role. At low temperature, the molecules move very slowly, the response time increases, the displays appear to be sluggish. At higher temperature, the molecules respond more quickly and faster image transactions may occur. So we have to maintain a constant temperature, not it should be a variable one. So there are so many advantages as well as disadvantages are there. Particularly the advantages of LCD, we can say it consumes a very low power, a low operating voltage, a thin and lighter construction, a flexible display design, the minimal heat generation, longer life, and it is suitable for battery operated devices. The disadvantages, we can say the LCDs are not self-luminous and require ambient light or backlight. The slower response compared to LEDs or OLEDs, a limiting view angle. The temperature sensitive nature is another drawback of LCDs. Lower contrast than modern OLED displays. These are the prime drawbacks of LCDs. Where we can use the LCDs are commonly in digital watches, scientific calculators, as well as in mobile phones, in the laptop displays, as well as in medical instruments. We can also use for industrial control panels as well as in automotive dashboards. So these are the avenues of areas where we can use the LCDs. In the next slide, we are going to see about the optocouplers. We can say opto isolators also. What are optocouplers? An optocoupler or opto-isolator is an electronic device that transfers the electrical signal between the two isolated circuits using light. It provides electrical isolation, that is very important, while allowing the information to pass safely from one circuit to another. So where is the need for optocouplers arise? So the protection of low voltage circuits, control circuits needs this one. The elimination of electrical noise needs this one. The prevention of ground loops needs this one. So optocouplers achieve these objectives by transmitting the signals optically rather than electrically. That's what important thing of optocoupler. So the optocoupler has various performance parameters that we are going to see. So these are the metrics that can be applied for optocouplers for the selection or for the buying, whatever it may be. The optocouplers namely consists of the following units. Actually, it will have one input device, optical path, and output device. So the input and output sections are electrically isolated but optically coupled. For example, the input device may be a LED. The optical path, as you know, can be a dielectric medium or air or whatever it may be. The output device may be a phototransistor, a photodiode, or photo SCR or photo triac, whatever it may be. So the various parameters are the forward optocoupling efficiency, the isolating voltage, the input current, the VCE max, that is nothing but the transistor maximum emitted collector voltage rating, that it limits the supply voltage that can be applied to the circuit, as well as the bandwidth. Bandwidth is nothing but the range of frequency signals that can be used for successfully coupling the optocouplers. So these are the prime factors that we have to take into account before deciding about the optocouplers. The optocoupler operation is a straightforward one. From the diagram we can observe a forward current flows through the LED. The LED emits infrared light. The light travels across the insulating gap. The photoresist sensitive output device detects the light. The output device switches on and reproduces the input signal. Because the signal is transferred only by light, there is no direct electrical connection between the input and output circuits. From the diagram, we can see the photodiode, a phototransistor, a photo Darlington pair transistors, a photoconductor, as well as a photo FET. how it has been optically coupled but electrically isolated. These gives a various examples for optocouplers. The first one uses both diodes. The next one uses one photodiode as well as phototransistor. The third one uses a diode with a Darlington pair transistor. The fourth configuration uses a diode with LDR. The fifth configuration uses a diode with photo FET. So these are the various permutations and combinations that are available for selecting the optocouplers. So the latching optocoupler configuration, you can see the photo SER, the photo diac as well as the photo triac. So you see these are optically coupled but electrically isolated. The input device may be a photodiode, whereas the output device that is used is a photo SER. In the second case, it is a photodiode versus photodiac. In the third case, it is a photodiode versus phototriac. So in this way, we can have various combinations based on our requirements, based on the performance metrics, we can select them. So these are the various important combinations that we have seen. The important parameters may include this one also, that is the current transfer ratio, that is called the CTR. So it measures how effectively the input current is transferred to the output, then the isolation voltage, then the input current, and the maximum collector to emitter voltage as well as bandwidth, as I already told you about this. So these are the various factors that we have to take into consideration. The primary advantages of the optocouplers are it provides electrical isolation, fast response, wide bandwidth, and easy interfacing, very compact in size as well as light in weight, very effective in elimination of the electrical noise as well as transients. Where we can use this optocouplers, that we can say for industrial automation, for PLC interfaces, as well as industrial control panels and systems. It is widely used in power electronics, particularly in SCR triac applications, as well as SMPS, inverters, and UPS system. It is widely used in communication systems also, as well as in medical equipments also. It is used widely in automotive electronics also. So these are the various references that I have referred for making the slides. Once again, thanking you one and all for hearing my lecture patiently. Thanking you one and all.